Hello everyone, here I am Vadil Sagar. Okay, so let us continue our discussion regarding the electric charge and field chapter, standard number 12, chapter number 1, and here we are at the part number 6 discussion. Okay, so here we are putting today the example number 1.8 of the NCRT textbooks. It's a very easiest example. Let us continue and let us understand what they are trying to explain you here. An electron fall through the distance of 1.5 centimeter. So they have a two plate and this distance is 1.5 centimeter. In the uniform electric field of a magnitude, some magnitude of electric field is given in the figure this. The directions of a field is reverse, keeping its magnitude uncharged, and a proton fall through the same distance. Compute a time for the each of its contrasts the situations with that the free fall under the gravity. Okay, so here we have in a particular first case we have a two plate which is separated by the 1.5 centimeter, and the upper plate is a negatively charged, downward plate is a positively charged. Another case we have separate case where we have positively and negatively. So the electron in this case, proton in this case, electron repel, and it will attract towards the positive, it will go downward side. This is the directions of the down electron. This blue arrow shows the directions of electric field. As you know, from the positive it will be emerging, it means goes outward, and then in the negative it is a inward direction. So this, according that blue lines is the electric field lines, and the directions, this arrow is the black arrow shows the directions of the charge. So here positive repel, and it's attract or goes towards the negative terminal. Okay, let us go ahead, and what we have to find, try to understand this. Computer time of falling, how much time it can take from to reach this to this. Okay, let us go for the discussion. The field is upward, so the negatively charge is going to be experience a force downward. So that force, this is the electric force, is F is equal to EE, as we know. Now onwards you should know, because in the maybe fourth part we discuss about the electric field equations, and we already know the F is equal to fundamental equation MA. Let us equate this. A is equal to B is equal to A is equal to C. So the EE is equal to MA. And now from this equation we can compute the A, which is A is nothing but the acceleration, EE by M. Now from the EE by M, kept it, this we know the time required to fall, free fall under the gravity, we learn in the 11th class in a motion chapter. The T is equal to under root 2 time of whatever height it fall upon its acceleration. If acceleration is more, the time will taking less. It means you more faster you go, it will take less time. So the here what AE, it means acceleration of the electron, that we already know, EE by M. You are putting the EE by M is goes up. So the overall, this is the time taking for the electron to travel the distance 1.5 centimeter h. The respective numbers, E2 you know, H you know, Me you know. Me is the mass of the electron, 9.1 into 10 to the power minus 31 kilogram. This is given here. It is the electric field is given. Then you will get able to find the answer at the TE, time taking by the electron to travel the 1.5 centimeter distance, is 10 to the power minus 9 second. It means few nanosecond, 2.9 nanosecond I can say in this way. Okay, let us go for the same discussion or the same calculation for the proton. There only the mass difference are only taken place into the pictures of the electrons and protons. So same in the AP, it is the acceleration of the P, EE by MP. T you are putting and AP you are putting, so the same process you have to do. Then you will get an answer is a 1.3 into 10 to the power minus 7 second. Now try to understand, here we have 10 to the power minus 9 second, and here we have a 10 to the power 7 second. Which one is bigger? 10 to the power minus 7 is bigger number. It means proton is taking more time to reach the 1.5 centimeter. Actually the proton is a heavy material. It means when heavy body, once it is fall, it should be fall first, it will take less time. But what happened in our calculations, the proton is taking more time. What is this? So this is happen actually due to the we are neglecting here the free fall under the gravity. Here we are neglecting the accelerations of the gravity. That's why this kind of sort of problems are occurring. It is not a problem where the time required to falling the h height is electron to proton is a different, and the electrons is taking less time than the proton. That at the end you have to make a judgment. This is contradictory because electron is a light particle than the proton, then it should be take more time than the proton, but not happen in our case because here we are ignoring the acceleration due to the gravity. So at the end, to justify the proper answer of this, ap is equal to ee by mp. It is not a new, earlier we've seen. What is e? 1.6 in number. What is E is given. What is mass of the proton? 1.67 into 10 to the power minus 27 kg. If you calculate in your calculator, you will get 1.9 into 10 to the power 12 meter per second. This much acceleration, 10 to the power 12. And what is your acceleration due to the gravity? 9.8 just in a finite number. And here the accelerations of a proton is 10 to the power 12. So think about it, it's a too huge number. The acceleration due to the gravity, the accelerations of electrons even greater than this effect is acceleration due to the gravity can ignorable because it's a just 9.8 and this is number is 10 to the power 12. So in this huge 10 to the power 12, just we are adding the 9.8, it will not much contributing. This is at the end you can make a judgment. Today we are doing this new topic is about the electric field, and not only electric field lines, because the as we have an idea about the magnetic field lines, this same phenomena in electric field lines. So according the whatever the fieldness or the whatever the sense of electric field comes only due to the electric field lines. So this is also important to know about the what is exactly meaning of the field lines. And now the further in the 2 to 3 slides is nicely explained this what the fundas in our ncrt textbooks exactly. From there I am taking the all things. So let the point charge be the place at the origin. Suppose anywhere charge is for charge we have, draw a vector pointed along the directions of the electric field with their length proportional to the strength of the field at the each point. As you can see in the figure, so at the one center you have one charge and we are drawing some vectors, and these vectors are the innermost vectors are lengthier, and the next layers of the vectors are the shorter than that, and the next layer of the vectors are the shorter than that. It means your length of the vectors is shows us strength of the electric field. So as we go away from the point charge, the field strength, electric field strength is reduces. So you have to draw your vector, it is in the small size, so it will tells us about the give the idea about the decrement in the strength of it. As we know also, it is a 1 upon r square time it will decreases. As r is increases, you are going away from the point charge, it will obviously decrease. This is a very good thing in a field lines through you can able to understand. Since the magnitude of electric field at a point decreases inversely, same what we discussed, increases inversely as square of the distance of that point of the charge, the vector gets shorter and shorter as we go away from the origin, always pointing radially outward if it is positively charged. If it is negatively charged, the same thing from the invert arrows are there. It is very clear because earlier we seen that also. Okay, connect the arrows pointed in a one directions and the resulting figure represent as a field lines. Those arrow if you connect in such a way, longer, shorter, shorter, shorter in all directions, it is nothing but the field lines. Very easy things is actually. We thus get a many lines, all the pointing outward towards the point charge. Have we have lost the information about the strength or magnitude of the field now because it was continue in the contained in the length of the arrow? Question mark. No, Now the magnitude of the field is representing by the density of the field line. What exactly question? Have you lost the information about the strength or magnetic magnitude of a field line? Because it was contain a length of the arrow. Only the length of the arrow through you can able to make a judgment of the strength. So no, the representing the density of field, that is a one more view, the view of seeing the judgment to judge the electric field. The density of field lines E is stronger nearer to the charge, so that the density of field lines is more near to the charge. So for understanding of this last discussion, you should know about what is the density of field lines. Density, as a 12th standard student, you should know about the what is density. Density, it means how much dense it has in a per unit gram or per unit things. Number density, you know mole density, it means how much number in this per unit these things, and likewise the density, it means you are keeping volume fixed, but the number of field lines passes through the it is having more, or in some another case we have less. So the more line passes, it means I can say it is a more dense field. So the density of field line, the number of density in the specific volume, specific area is more, so it is more dense. So according, if it is more dense area, I can say it's more strengthful area, more strength of the electric field there. So in this way you cannot make a judgment of the length of the magnitudes of the vectors what you draw. You have one more parameters through which you can make a judgment very perfectly. The E is the stronger near to the charge. Why this is happening, I will explain you in the later. So that density of field lines is more near to the charge and the lines are closer. So the density are, if lines are closer, so the density will be increased, and density of the field lines is increased, it will tells us the strength of the field. Always away from the charge, the field get weaker and the density of field lines is going to be less. So resulting is well separated the lines. Okay, it means if you draw the arrow, the vectors and the very close, it means the field line, the field electric field of that charge is strong. No, for that way we cannot make a judgment. So that's why we have introduced a new concept of the flux or the density of the field lines. We draw one figure in a plane of paper, for example 2 dimension, because we are living in the 3 dimension. So but we have a 2 dimension for our drawing. So one wish to estimate the density of the field lines, one have to consider the number of lines per unit cross section area, which is perpendicular to the line. So the density of field is nothing but the, this is definition of, from that you can understand the number of field lines pass through this specific area. If you select the specific area, this S R, this is you are selecting in the R, the same area of S also. So number of field lines pass through the R, you can calculate 1 2 3. So the number of line pass through the R is 3, number of field lines pass through the S only 1. So the which, okay, so R region is a more strengthful electric field or the S? In R, because their number of field lines are the more there. So I can say density of the field lines in a R region is more. So it's a very easy to understand, but I'm going in detail. So those who are interested to understand these things can understand. Since the electric field is decreases as the square of the distance from the point charge, and the area enclosing the charge increases as a square of the distance, the number of field lines crossing the enclosing area remains constant whatever the may be having. So now trying to see in the figure, we are taking one area through which passes line we are capting fix. If we suppose we are taking this P1 area, blue one, and I'm take it as a, how many lines are there, 1 2 3 4 5 6 7 8 9, 9 lines are must pass through the area. Now the same P I'm shifting this side, but I want should pass with the 9 lines. Now if I'm keep remaining with this shape, then 9 lines can't be passed through it, so I have to increase my size of it. So think about it, if you want to keep remain with the fill lines, you have to increase your area. This way also you can understand, I can go in the reverse way. If you kept your area is fixed, the number of line passes through the will be shift. So either one of the thing is increase, either one of the thing is decrease. Okay, now this is the relative density of the field lines are the different at the different point. The field lines crowd where the field is strong. If it is more crowdy area of the field lines, it means it's strong. And the space apart, if it is a very spacey, it means we have a very gap between two field lines, it means it's a shows of weakness of the field. So I can say strongest field at the O. As I go ahead of the as I go away of its, there the field lines are the strongness of it decreases. We can imagine two equal size of area elements which is named as R and S. I already explained these things. Number of field lines in our pictures cutting through the area elements is the proportional to the magnitude of the field lines. As you can see, area is same. The number of field lines pass through those two elements in the same direction, you can see. I'm not changing even direction, otherwise you can make contradictions to me. Oh, you are changing the directions of that area element, so it maybe cannot pass through the same lines. But I'm just shifting here to here, and the number of field lines passes through it will be changed. So it has something. So there, as away from the pointer you are going, it means field lines are having a spacey, more weaker than. Okay, thank you very much. Actually this topic is bigger comparatively. So the whatever the discussions left of regarding this angles and all that, I will introduce in the next part number 7. Wait for the till this.